So we have here linear inequalities, right? So imagine we have, and I'm hoping that everybody here knows the difference between less than and greater than, right? The less than is the one that'll be like a L, and the greater than is in the other direction, right? So obviously this is greater than. The less than would be like a L, right? Another way of figuring this less than greater than thing is whatever is on the side, you see this bigger side? So basically we have the less than sign, which is like a L, and we have the greater than sign, which is in the other direction, right? And if you can't remember it, just know that where this less than and greater than sign comes from, it actually comes from an equal sign. And then you take the equal sign and you join these two sides like that, right? So it's an equal sign where one side of it is separated and the other side is joined, yeah? So the side that's separated, think about that as the greater. Whichever term is on that side will be greater than the other term, and this term is less because the distance is greater. So consider this, x is greater than -2, right? Now what this means is that x could be any real number greater than -2, yeah? Any real number greater than -2. And this is a common sense kind of thing. So don't let the algebra get you down. You know, it really is common sense, right? So we have a number line here, and this is how we represent x is greater than 2 on the number line, where we have an unshaded circle surrounding -2, -2 is what we're talking about. And then the arrow in this way signifying that x is greater than -2, right? So Shizzy and Scotia, you guys okay with this number line thing, right? Now here's the interesting thing, right? It works just like algebra where, you know, you have x is equal to -2. And if I want, I could add on both sides of the equation. If I want, I could add 2 or I could minus 2. I could do anything I want once I do it on both sides of the equation. So it works the exact same way. You can see here that we can add a number. So I have the x, I have the -2, and I add 2 to both sides, and it doesn't change anything. Yeah? I could subtract. So, you know, I have the x and I have the -2, and I subtracting 2 from both sides, and it doesn't do anything. It's, you know, the sign stays normal. You know, the sign is cool. The greater than, it's still greater than. And think about it this way, right? I have more money than Soraya. Yeah. So I have more money than Soraya. Right? So if I have more money than Soraya, right? You give me $2 and you give Soraya $2. Well, guess what? I still have more money than Soraya, right? That doesn't change anything, yeah? If it is that I have more money than Soraya and you take away $2 from me, but then you also take away $2 from Soraya, well, then I'll still have more money than her, right? Soraya, apparently I have more money than you, right? If I have more money than Soraya, x greater than -2, and I multiply my money by 2, and I also multiply Soraya's money by 2, I will still have more money than Soraya, right? It will still be greater than, right? If I have more money than Soraya, x is greater than -2, yeah? And I divide my money in half, but Soraya also divides her money in half. Then I will still have more money than Soraya, yeah? So we could see here that adding both sides of the, I can't say equation, this is not an equation, it doesn't have an equal sign, so I have to use, instead of using the word equation, I will use the word inequality, right? So adding something to the inequality on both sides doesn't do anything. Subtraction doesn't do anything. is quite normal. It works normal just like algebra. Multiplication of an inequality and division of an inequality works just like algebra, right? So is everybody okay with this? I'd like you guys to just sketch this real fast. Just give this a write down, and I'm waiting to hear 4 done it. Is it okay? All it's saying is that if x is greater than -2, or any number, if x is greater or less than whatever, once you add in on both sides of the inequality, or subtracting or multiplying or dividing, the inequality still remains true, right? And that is the whole thing about this topic, is how true is the inequality, because an equation with an equal sign is true, right? Equal, that signifies truth, right? That x is 2 or x is 3. But an inequality is different. An inequality is kind of fuzzy. You know, you still don't know what x is, but all you know is x is greater than -2, right? So this next note here is the tricky part too, right? This next note is the tricky part, and this is the part where all students just get things wrong, right? All the students just get this part wrong. Because you see here, when you're adding, you're subtracting, you're multiplying, or you're dividing, it doesn't do anything to the sign. The sign stays just the same, right? But if you multiply or divide by a negative number, the sign will actually flip. So for example, if I have x is less than 2 and I multiply both sides by a negative number, I multiply by -1, right? You'll have negative x on this side, you'll have -2 on this side, but look, I had to flip the sign. So now negative x is greater than -2, right? So here's the thing, right? X is less than 2, but if I multiply by a negative number, or you divide by a negative number, negative x, now I had to flip the sign, is greater than -2. My question is, why? Why do I have to flip the sign? Think about it for a minute. Alright, so here's what. Let me just do this example. X is less than 2. And what I'll do is I'll multiply by -1 on both sides, but I wouldn't flip the sign. So now I'll have negative x is less than -2. And you notice I did not flip the sign here, right? Now, let's try a substitution to see how true this thing really is. Let's just let x equal to 1/2. Right? So if I let x equal to 1/2, or let me just say, let's not use 1/2, let's use something easier. Let's use 1. I'll let x equal to 1, right? So you see, I plug that in there. 1 is less than 2, so that is totally true, right? But I multiply both sides by -1 now, and now I put the 1 in there, and look what I get. I get -1 is less than -2. And this is not true. If we look on a number line, this is 0, this is -1, this is -2. So we can see -1 is actually greater than -2. Yeah? So the whole point, and I don't want to over explain here, right? But the whole point of this, is that, and this is something that students, this is what this tie up students the most, right? If you just remember, when it comes to an inequality, if you are multiplying by a negative number or dividing, and multiply by -1, for example, you have to flip the sign. Once you flip the sign, now if I say if x is 1 then 1 is less than 2, yes. And if I put x to be 1 here, then negative 1 is greater than negative 2. So it remains true. Yeah? And this is the only thing about inequalities that students will find tricky. Everything else is just straight algebra. Right? The problem is that this here has a lot to do with transposition, because if it is that you had something like, let me just say, negative 2x is less than 4, right? And you want to solve for x. So you're going to solve for x just like any normal equation. You're throwing the 2 across. When you throw the 2 across, the problem here is that it's negative. Right? Remember, when you throw the 2 across, what you're actually doing is you're dividing by negative 2 on both sides. So because it's a negative, when it comes to multiplying and dividing, and that will do for transposition, because that is when we just multiply and divide, when we transpose in. So when you throw in that 2 across now, you'll get x. You had to flip the sign, and you could keep your negative 2. What we did there was we actually divided both sides by negative 2. And because we divided both sides by negative 2, we had to flip the sign. Yeah? This here is the one thing that will get you tied up with inequalities. This and this alone. The rest of it is easy. So give this a write down real quick. Let me hear 4 done it, and then we'll look at an example. They do love to bring inequality questions in CSEC. There is at least one part of a question in the paper 2, and maybe one question in the paper 1 that will be on inequalities. So let's take a look at an example of all of this. Now the whole point here is, what I'm trying to tell you is this. When you're dealing with an inequality, you want to solve x. You want to solve for x. You treat it just like any other equation. So you could add 2 to both sides, you could minus 2 to both sides, multiply 2 to both sides, divide 2 to both sides, and everything normal. Just like we just do in normal algebra, except for if you are dealing with a negative multiplication or division, right? So let me check and see how it is worked. We have here this example where we want to solve for x essentially, and we are solving the inequality 3 minus 2x is greater than or equal to 5. Right? So we treat it just like any other equation. Right? What's the first thing that we'll do? We'll we go throw across the 3. Yeah? So now we go have negative 2x is greater than, you notice the sign didn't change because we didn't really do anything, 5 minus 3. What do we do? Remember, when we transpose, when we throw across the 3, what we actually doing is minusing 3 from both sides. Right? And addition and subtraction doesn't affect the sign. So transposing this 3 is not a problem. So now we have negative 2x is less than or equal to 5 minus 3. Negative 2x is less than or equal to 2. Right? And I think everybody would have reached here with no problem. But then we had to transpose the negative 2. And because it's a negative and it's a multiplication, means that we really actually divided by negative 2 on both sides. And because of that, we actually had to flip the sign. So it's no longer a less than, it's now a greater than or equal to. So x is now greater than or equal to negative 1 is the final answer. Yeah. So one more time, when it is that we have an inequality, we treat it like a normal algebraic equation. You solve for x. You throw the 3 across, right? It becomes negative 3. The sign doesn't change. But the sign will actually start to change once you deal with this multiplication here. When you throw that negative 2 across, right, it'll become x is greater than or equal to, the sign has to flip, 2 divided by -2. Right? So think about if you have a multiplication or a division, and once that negative crossed the gate had a flip. You know, you could think about it like that. Right?
Wait, so you basically treating the sign in the middle as an equal sign unless you have to transpose a negative number.
Pretty much. It's just the same as a normal equal sign. So I could have 3 minus 2x equals 5. And I could have threw across the 3, so I could have -2x equals 5 minus 3. -2x equals 2. And then x is equal to 2 divided by -2x equals -1. So you could see here that I did the exact same thing as if it was an equal sign. Yeah, I even get the same answer as if it was an equal sign. Right? But the only thing is that when you are transposing a negative multiplication or division, you have to flip the inequality. So essentially now, one other thing I wanted to point out, and let's just go over here, right? You see how when we said x is greater than -2, it didn't have no greater than or equal to it. It just had greater than. So when you just have greater than, you're using an unshaded circle, right? Unshaded circle, and then an arrow pointing in the direction of greater than or less than, depending, right? However, in this case, we have greater than or equal to. So that means that the -1 is included. And because the -1 is included, you see now we have a shaded circle. Right? So this is another thing that you could lose marks for. Right? So remember, if it's just a less than or greater than, you put an unshaded circle. But if it's a less than or equal to, you put a shaded circle. And we can actually illustrate that here. So let's just put a little note there. Less than, greater than implies unshaded circle, or less than equal to implies shaded circle. So give this example a write down so you can see here the example. The final answer we got was x is greater than or equal to -1. So on my number line, a shaded -1, and my arrow is going in the direction of greater than, right? Being that all of these numbers are greater than -1, and so all of these numbers can be x, right? X is not just one number. X is a whole range of numbers now. It have another kind that is look kind of scary. So this next question going to look kind of scary, but it's just the same thing over and over again. So check this question, right? You actually want to solve for x, but look how this looking. Yeah? This have x minus 3 is less than x, 2x plus 1 is less than 5. Now we've seen something like this before. Like if I had x is less than 2 and I have 4 over here, right? We've seen it's like a range, right? Where x is greater than 2 but x is less than 4. Yeah? So this expression here now is greater than this one, but it's less than this one. So how do we solve something like this? Right? It's not like it's one equation. You have to understand it's actually 2 different equations. So we have to take these 2 equations and work it out here. Right? And then we will take these 2 equations and work it out here. So you can see it's just the same procedure, but we kind of had to split it up. So let's just take a look at these 2. We're going to take these 2 now and work it out here. x minus 3 is less than 2x plus 1. And obviously I could take the 2x and fling it across, right? So it becomes x minus 2x, and the sign stays the same, right? And obviously I take this negative 3 and I fling it across to get 1 plus 3, right? So the sign stays the same there, right? X minus 2x is negative x, that's minus 1. 1 minus 2 is minus 1, yeah? And so I have negative x is less than 4. Well, now I have to multiply by negative 1 on both sides to get rid of that negative x. So now you see the sign flipping. Positive x now is greater than negative 4. So that is the first answer that I got there. So you could see that through the entire process, I treated it just like a normal equation. It's only when I had to multiply or divide by a negative number, I could have said I divided by negative 1 on both sides as well, right? And that is when the sign had to flip, right? So the final answer ended up being x here is greater than negative 4, right? Now let's work out these two, right? So we're taking these two now and we're working them out here. So you can see that 2x plus 1 is less than, 5, right? So I could take the plus 1 and throw it across to get 2x is less than 5 minus 1. 2x is less than 4. It don't have no negatives to deal with here, so I could throw across the 2 and I don't have to worry about flipping the sign. No negatives in there. So x, the sign stays the same, is less than 2. So now I have two different answers because you know this is a range. Just like how when I had x is less than 4 but it's greater than 2. That means that on a number line I have 2 over here, I have 4 over here. So x will be between the two of them. Yeah. So you kind of get the same thing for your answer because look, I got for one answer x is less than 2, but for the other answer x is greater than negative 4. I could have rewritten it like this: x is less than 2, but it's greater than negative 4. I could have rewritten it like this, and this is how it will look on the number line. You notice it's unshaded because I don't have the equal sign. So first I will draw an unshaded circle around 2 because x is less than 2. I'll draw an unshaded circle around negative 4 because x is greater than negative 4. So that means x is greater than negative 4 in this direction. X is less than negative 2 in this, less than 2 in this direction. And so this is the portion of the line where you have to shade. This is the portion where you might find x. If you was looking for x, you would have find it somewhere in here. And if you want, you could just give this a write down. This is just like a summary of everything we just talked about there. Remember, there is no equal. If there is no equal, then the circle is unshaded. So this is the example here. And if there is an equal sign, then the circle is shaded. So we have this example here. So give this a real quick write down real fast and let me hear. Let's try number 1 and number 2. And remember, when you get your final answer, you have to show it on a number line. And I'm just going to treat this like any other thing. I might want to put all of my x's on one side. So I'll throw this 3x on this side. And I'll throw this positive 4 on this side, right? So if I throw the 3x on this side, I'll get 5x plus 3x. And that doesn't change the sign. None of this changes the sign. And I'll put the 4 on this side. So that's 3 minus 4 this time, yeah? So 5 and 3 is 8x is less than or equal to negative 1, and therefore x. Now even though the 1 is negative, I really just throw in across the 8. And the 8 is positive. So what I'm actually doing is I'm dividing by 8 on both sides. That is positive, right? So nothing will happen. Nothing will happen here. If it was -8, then I had to divide by -8 on both sides. Then you would have had to change the sign. But no, you don't have to change no sign here. So this is x is less than or equal to, the sign didn't change at all, -1/8. And then you have to draw your number line. This is 0. This here is -1/8. Right? You'll have a unshaded, no, it's a shaded because it's equal. Shaded, and then you could draw your arrow going up like that in that direction. I'm not seeing, I don't think that this will end up being a negative either. So you might not have to flip the sign here either. Right? I'll throw across the 2y on this side, and I'll throw across the -6 on this side. So I'll have 5y minus 2y, and the sign will remain the same, -7 plus 6. So on this side, I will have 5 minus 2 is 3y, and on this side, I will have -7 plus 6 is -1. So again, I am dividing by 3 on both sides. This is a positive number. If this was negative, I would have to flip the sign. But this is positive, so I don't need to flip the sign. Right? So y is less than or equal to -1/3. 0, this is -1/3. And yeah, is less than or equal to, so you do that, and you could just draw your arrow like that. Right? Some people will, if this is 0 and this is -1/3, some people will do that, and they will actually draw the arrow coming from the top of the circle like that, and that is fine, so that you can see it a little better. Right? So Scotia, she's
arrow. How come I don't do the next direction?
Oh my god, it's supposed to. Thank you. Yes, wow, thank you very much. So that is my mistake. Yes, thank you very, very much. And Scotia, you get maximum points for that. Thank you so much, because they are both less than, right? So I don't know why nobody correct me there. Shame on you all, but shame on me for teaching all the wrong thing too. But yes, they're both less than, so they both have to go in this direction. That is so true. Thank you very much, Scotia. They both have to go in this direction. Right? We're moving on to slightly tougher things. Right? And this is a question they love to bring in CSEC. And now we're talking about graphing. So you have the number line here, but now we're talking about graphing. And how do you graph an inequality? You graph it in the same way like if you were in coordinate geometry and they give you an equation and you find your 2 points. Yeah? So you have to do that here as well. Right? So first, graphing linear inequalities, and of course you don't need graph paper for this. This is just an example, so you will just write this or sketch it in your book somehow, right? Shade the region that of the graph to represent x is less than 3. So if x is less than 3, what I'm going to do first is I am going to pretend like if it's an equation, x is equal to 3. And what I'll do is I'll draw this line. And let me see how much people remember the coordinate geometry. Is the line x equal to 3 a horizontal line or a vertical line? Vertical. Thank you very much, right? So x is equal to 3 is a vertical line passing through 3. So I will draw this vertical line here. Right? And don't draw that line yet, because it's not supposed to be a solid line, right? So we're going to talk about that just now, right? So it's a vertical line, and what I will do is, if I had x is less than or equal to 3, I would draw a solid line. But I don't have equal to, I have less than. So I'll draw a dotted line. So this is the dotted line, x is equal to 3, right? There's a vertical line. Now, we have to shade the region of the graph, right? So the first thing we do is we have to draw the line, and now we have to shade the region where this is true, right? So which side of this line do you think represents this region? Right? We have the right side on this side and the left side on this side. So which side do you think represents x is less than 3?
The left side.
The left side, because obviously here x is 3 here, so you see here x is 2, x is 1, x is 0. All of these numbers on the number line are less than 3. Yeah, so it's definitely this side. So what you have to do is you have to shade the entire region of the graph. So for this entire region of the graph, x is less than 3. So give this a quick sketch and let me hear 4 done it. So now we have this next one here. And now with this next one we could see shade the region of the graph to represent x here, and I know it's kind of small, so I'll just rewrite it. X is greater than or equal to -3. So again, what I will do is I'll pretend like I'm drawing a lambda line. X is equal to -3. Right? And you notice in this case is a greater than or equal to sign. So that means that it includes the -3. So in this case, I will actually draw a solid line rather than a dotted line. Yeah, so -3 is here. So this will be the solid line. X is equal to -3, right? And the region where x is greater than -3 is which region? The right side of the line or the left side of the line?
Yeah.
All right, you see this is -3 here. So that means that -2, -1, 0, 1, 2, all of these are greater than -3. So that means that this is the entire region of the graph that I have to shade over here. So you actually shade this whole region. And this is the region of the graph where the inequality will be true. Right? So you notice in this region here, the inequality does not hold. Yeah, because x is less than -3 over here. But in this shaded region, the inequality is true. So let me hear 4 done it, or at least 3 done it. So now let's take a look at this one. Right? So to my coordinate geometry junkies, the line y is equal to 3. That's a horizontal line now. Yeah? And we could see here that this inequality y is greater than 3. Right? It doesn't have an equal, greater than or equal to, so I have to use a dotted line. So y is equal to 3, well that'll be here, so I will use a dotted line to draw y is equal to 3. Right? And now with the inequality, y is greater than 3, so obviously in this upper region, 4, 5, 6, 7, that is where y is greater than 3, so I will have to shade that portion of the graph. So moving on. So now we have the line y is less than or equal to -2. So again, the first thing I will do is draw the line y is equal to -2. But you notice y is less than or equal to -2. It has the less than or equal to. So that means it includes the -2. So that means I will use a solid line this time, right? So -2 is over here. So I will draw the solid line y is equal to -2, right? And now I will shade the part where y is less than -2, which is below the line. So all here is where y is less than -2. Easy stuff, right? So now here is the kicker, and I'll see how well you guys really understand it. Right? Boom. Shade the region of the graph that represents y is greater than 3x minus 1. So you know, the first thing that we had to do is we have to plot the line y is equal to 3x minus 1. So let's draw that line, and in order to draw that line, I need 2 points. Yeah? So let's try when x is 1. So when x is 1, what will y be? 3 ones are 3, minus 1 is 2. So the first point, when x is 1, y will be 2. So I'll come here when x is 1, y is 2. That is my first point there. Now let's talk about the second point, when x is 4. Let's try that, right? When x is 4, 4 3s are 12, right? And 12 minus 1 is 11. And anybody could hope you all could correct me if I'm wrong there, right? So we could see that when x is 4, y is 11. So we see here that is not a straightforward case. We actually have to plot a line here. So we got 2 points, 1, 2, and then 4. When x is 4, y is 11. Wow, that's all the way up here, right? So now what we have to do is we have to draw this graph, and to draw this, if you notice, y is greater than 3x minus 1. It doesn't have an equal sign there, so I'm going to have to draw this with a dotted line. So I will try to see if I can average a dotted line. When x is 0, y is negative 1, so that's passing there. And I could just, I hope you guys use a ruler to draw this, because mine is not going to be very straight. Right, so now this is the line, y is equal to 3x minus 1. And I hope everybody understands how to draw a line, right? Now comes the question. We need to shade the region where y is actually greater than 3x minus 1. Yeah? And in all of the other examples, it was clear cut to know which region to shade, less than or greater than, because it was horizontal and vertical lines. But now we have our bend line, so it's a little less clear cut. So do we shade this region? Let's call this region 1 on this side of the line, region 1, and let's call it region 1. Or do we shade region 2 on this side of the line here? Which side do you think we need to shade in order to satisfy y is greater than 3x minus 1? Which side do you think it would be true? What we have to do is this. It's not clear cut. I don't know which side to shade, right? Y is greater than 3x minus 1. I don't know which side to shade. Which side would that be true? Well, what we'll have to do is we'll have to test each side. So we'll have to have test points, right? So let's choose a point on side 1 over here. Let's choose this point here. All right, this point is the point what? 4, 4, right? Yeah, so this is the point 4, 4. Now remember, this point 4, 4 is not on the line. So if I was to put 4 in this equation for x, I am not going to get 4 for y. I'm not going to get 4 for y. And actually, because we're dealing with less than or greater than, let's not choose 4, 4. Actually, yeah, let's choose 4, 4. No problem. We already chose that, right? So this point is not on the line. So don't expect to plug in 4 for x and get 4 for y. No, right? But I will plug in this point in the inequality, right? So if I say x is 4 and y is 4, what I'm going to end up with? 4 is greater than 3 times 4 minus 1. 4 is greater than 4 3s are 12 minus 1 is 11. Is 4 greater than 11?
No.
Right. So therefore it can't be region 1. It can't be region 1 at all. So obviously it have to be region 2, but let's prove that it is region 2, right? So let's choose a point in region 2. So let's choose this point here, negative 2 on the x and 2 on the y. Negative 2, 2. That is this point here. So let's put that point in, right? Y is greater than 3x minus 1. So I'll put negative 2 on the x, and that is greater than negative 2 on the y. So negative 2 is greater than 3 2s are negative 6 minus 1. Negative 2 is greater than negative 7. Is negative 2 greater than negative 7?
Yeah.
Yes, so this is true and this is not true. Right? So that means that now I could be sure that region 1 is not it and region 2 is it. So I have to shade this side here. So just to recap, when you are given an inequality in the form of a line, you plot it like any other line using your 2 points. Right? Remember to use a dotted line or a straight line depending on if the inequality has an equal sign or not. In this case, it doesn't have the equal sign, so we use that dotted line. So we plot the line using 2 points. But then we didn't know which side to shade, so I chose a random point in this region, and I saw that it did not satisfy the inequality. It was not true. So then I chose a random point in the other region, and I saw that it did satisfy the inequality and that it was certainly true. You all try this one now. Shade the region of the graph to represent this. Right? And of course this has a less than or equal to sign, so that means you're going to be drawing a solid line. So I'll give you all 5 minutes. Remember, step 1 is to actually draw the line y is equal to negative 4 plus 3. So actually draw the line. And then step 2 is to test the regions, right, to see if they work or they don't work. And then you could know which side to shade, right? So 5 minutes. So first thing is first, let's draw the line y is equal to negative 4x plus 3. So I'll choose x is 1. When x is 1, 1 times negative 4 is negative 4. Negative 4 plus 3 will give me negative 1 on this side, right? So when x is 1, negative 4 plus 3. When x is 1, y is negative 1. So we have the first point, 1, when x is 1, y is negative 1. Right? Obviously, when x is 0, y will be 3. Right? So, because this will totally cancel off, so y will just end up being 3. So when x is 0, y is 3. That is the next point there. When x is 0, y is 3. So we have this line kind of going like that, and it's a solid line, so I'll draw a solid line. And I don't have a ruler, so that line is horrible. I humbly apologize for that horrible line. I hope you guys use a ruler, right? So now let's check and test which region should I shade, right? So let me take Let me take the origin 0, 0. Alright, to be in this region on this side here. 0, 0 is the point that I'll take. Alright, so to test if that is true, y is less than or equal to negative 4x plus 3. So I'll put 0 here, and I'll put 0 here. So in this case, 0 on the y is less than or equal to, well, this gone, so I'll have 3. We could see here that 0 is less than 3. And yes, that is true. So 0 is less than 3 means that this here is the region that we will have to shade. Okay? Because a point in this region proves to be true. So all of the points will prove to be true for this inequality. Yeah? Nice. So did you all get that? Anybody have any questions or anything? All right. So for homeward bound, this is the kind of question. So this is the last question we'll do for the day. All right. Now imagine this. Imagine a situation like this, right? All right. Like in this case, I had y is greater than 3, right? And what if I had another inequality? What if I had the inequality x is less than 4, right? So you know that I would have to draw the line x is equal to 4, and I would have to shade this region here. Right? And if you look at it, you will see that this region is common to both of them, and this region here have both y is less than 3. No, sorry, y is greater than 3 and y is less than 4 is true for this region here. Right? So you can see that this is the region that is common for both of them. Right? So that is what you have to do for this question. You have to actually draw all 3 lines, shade all the regions for each line, and see which portion is common to all 3 of them. Right? So I'll give you 5 minutes to do this. So let's take this and see how this is going, right? First, we have to do the line y is equal to x, right? And of course, you know, if we could plot the 2 points, well, when x is 1, well, y is equal to x, so y will also be 1. So we have the first point 1, 1. And then we could choose when x is 4, y will also be 4 because y is equal to x, right? So 4 on the x, 4 on the y gives us that. And let me see if I could draw an accurate line this time. So I'll use the line drawing tool if I could find it. Insert a line. Right, so that there is the line y is equal to x, right? And let's just draw all of the lines first before we start shading stuff, right? So what do we have next? We have the line y is equal to 5. So we know the line y is equal to 5 is actually, and I'll just copy and paste that, is actually a horizontal line, is it? Cutting at 5, right? So 5 is around here. So we have the line y is equal to 5. Now let's do the other line. Y is equal to negative 3x plus 5, right? When x is 0, then this whole thing will cancel off and y will end up just being 5. So the first point is 0 on the x and 5 on the y. So that's the first point there. The second point, y is equal to negative 3x plus 5. Let's see, when x is 1, then y will be Negative 3 times 1 is negative 3 plus 5, which is 2. So when x is 1, y is 2. So I have here, when x is 1, y is 2. That there is my second point. And now let me see if I could draw this line. So now we have the 3 lines drawn. We have over here the line y is equal to x, the black line. We have the line y is equal to 5, the orange line. And we have this other line, y is equal to negative 3x plus 5 there. Right? Now let's see which are the common regions, right? So we have to try to find which are the regions that we want, right? So for this one, it's pretty easy. We want anything that is less than 5. So we want this entire thing here. That is less than 5. So we want below that line, right? So that is okay. Now for this one, right? And let me erase all of this. For this one, we have to test and see, right? We want where y is greater than x. So if we choose, remember that's this line here. So if we choose a point on this side, let's choose this point here, 4 and 8. Yeah, so we could see that when x is 4, y is 8 for this point here. And is 8 greater than 4? Yes, it is. So we could see that the upper part of this line, the upper region, is going to be shaded here, right? So now let's choose this line and see. So that's the red line coming on this side here. Which side do we shade there? Well, let's choose a point on this side first. How about we choose 0 on the y and 4 on the x, right? So I have 0 on the y and I have 4 on the x. 4 times negative 3, that is negative 12, plus 5, 8, 9, 10, 11, 12, 7, that is negative 7, right? So what do you have? 0 is greater than or equal to negative 7. And yes, that is true. So for this red line, it's this region here. So for the red line is this region. For the orange line is this region, right? And for this line, y is equal to x, is this region. So we could see that the region that is common to all of them would be this little triangular region here. This little triangular region, if we look at it, it includes the y is less than 5. It includes the y is greater than x, right? From this line, y is greater than x, right? From this line, y is less than 5, and then from this line, y is greater than negative 3x plus 5. This is the region here that is common to all of it. So this is the region, and these are the vertices that you would have had to have the points for, that you would read off of your graph to find the points for that. So let me ask the question, how did this question treat you all? How did you all understand this one?
Yeah.
And of course, I mean, you're shading up and down the place, so it all seems really really confusing, right? So I mean, you could tell that in a question like this, you might want to shade really lightly until you're sure, you know, what you're dealing with, right? So if I just do this here, you could see that for this line, y is equal to x, it was the upper portion of the line that was shaded. So this entire upper region here, right? For this line, y is equal to 5. It was below that was shaded, right? And then for this line, negative x plus 5, it was this side of that line that was shaded. So you can see here that the common part for all three is this little triangle here, and that is the common region that inside of this region here, right? Remember, when you find two simultaneous equations, what you're finding is one point that satisfies both the equations, right? In this case, what we're finding is an entire region. So you see that region inside of this triangle here? If you choose any point inside of this triangle, right? Once it's inside of this triangle, any point inside the triangle would satisfy all three inequalities, right? And that is what we actually do. We find in a region that would be true for all of these inequalities here, right? So I have a question for you guys, and I mean, obviously this here, and a way to take a screenshot of this. So this is your homework here. So just take a quick screenshot of this real quick.